Hey everyone, and welcome to the Future of Intralogistics Days. My name is Andreas. Most people know me from Irgendwas mit Logistik. Some people know me from my engagement with AutoStore. And I'm really happy to be part of the Future of Intralogistics Days together with my co-host Julian from Wiferion. Julian.
Hi, yeah, good afternoon. I'm Julian. Thanks for introducing, and welcome also Andreas to our little event, Future of Intralogistics Days. We're very excited and hope you're going to have a good time over the next couple of hours and experience something very innovative and new from the world of intralogistics.
Good time is a good phrase to also reflect on what is currently ongoing in the world, and we all know that it's not that easy hosting an event, participating on events, focusing on the day-to-day business with all the stuff going on, starting from the last 2 years with COVID and recent developments in the conflict between the Ukraine and Russia. But we still try to look forward and try to have a great day with interesting speakers and experts from different fields of the intralogistics. But we can't forget what is currently going on in the world, and that's Julian, maybe you want to add a couple of words from Wiferion perspective and how you perceive the situation.
Yeah, of course, we are also very upset and sad what's happening at the moment. We have roughly 60 employees at Wiferion, some people from Russia, some people from Ukraine, and it's very heartbreaking what's happening. But I think it's very important from our point of view that we keep that parallel world, not forgetting what's happening on the other side, looking to the future and also supporting as much as possible. So from Wiferion, we decided that we will donate every contribution that we ask from all of the participants, and we are very grateful that so many companies joined us today. We will donate the little contribution which we ask for to a rescue company, an NGO that helps people in need at the moment. So yeah, let's still look forward, because I think one thing what we all have in common, bringing people together and loving intralogistics. So maybe that's a term we can rephrase to share love and focus on what's coming in the future. And Andreas, what happens in the future?
What happens in the future? Nobody knows. There's many people who believe that they know. Let's see who is right at the end. That's the history that shows who has been right. But let's maybe discuss a little bit before we start into the expert discussions and the agenda of today, why we actually are here and what we are actually doing. So yeah, my first question towards you would be, why do you guys from Wiferion actually host an event calling the Future of Intralogistics? Do we want to talk a lot about battery management systems today and tomorrow?
Maybe yes, but the focus, it's not about presenting our product, wireless charger or batteries. It's more about bringing people together. When I think it was around end of last year, and the Logimat was postponed, which is, as you might know, one of the most key shows and events during the year, normally hosted in March. During those times, we decided that's a really pity that COVID again made some kind of a problem in realizing that event in March, and we said, isn't it most important, what we love on shows is getting together with people, sharing news, looking at innovations, talk about how the future will be and what's new in the market. And we decided, let's use that webinar and the digital solution which are possible at the moment to bring new stuff together, new innovative products, new ideas, some success stories of people, everything tailored around intralogistics. And now we are here. We call it Future of Intralogistics. Hopefully, we and our guests and presenter will guide you through the new way of future and finding new ideas which might help you in your companies, maybe also in your private life, to improve business and life.
I remember the first time you guys reached out, you had a different naming about it, and you came up with, it's a really hot event and it's called Hot Motion. I was like, okay, that's maybe not what I would expect for an event. So glad we renamed it to the Future of Intralogistics. Sounds a bit more serious and actually reflects on what we're going to see. And going to see is the actual switch and introduction to the agenda. So there's a couple of experts today and also tomorrow. And we're starting with Sherpa, who are actually going to present as first in actually a couple of minutes. So we need to hurry up with the agenda, not delaying the first spot of today. Followed by Magazino, a robot company from Munich in Germany. Following by a live discussion actually here on site with Zig. And then following up by 4 different slots of remote experts that are actually straight into the stream, and then followed always by a couple of questions, which are then Safelog, PohlCon, Identpro, and ending up the day with Flexqube. And there's also a tough agenda for tomorrow as well. So it's definitely not getting boring. I'm pretty sure there's something for everyone. So we, as you see, we have various aspects of intralogistics with a certain focus today on automated mobile robots or autonomous mobile robots, however you want to call it, phrase it. But I think that's a really intense agenda and really some stuff to look forward to. And I hope everybody is actually having something which says, okay, I can take something with me, I get some key learnings and get some understanding of how to actually approach the future of my intralogistics in this particular case.
Yeah, thanks, Andreas. And let's look into the future now. I think we will start in a minute. Let's quickly introduce the speaker. We'll have Stefane from the company Sherpa Mobile Robots. It's a French company. We know them since a couple of years. So we meaning Wiferion. We're looking at a couple of projects together with them. I'm quite sure Stefan will also give you a good insight of it. And yeah, Stefan, I see you digitally. I hope you can hear me and see me as well. Greetings to France. Hope everything is fine. Bonjour.
Hello, everybody. Do you hear me?
We can hear you well.
Good. So I would say the stage is yours, and have fun, enjoy it, and everybody on the cameras and on the screens, feel ready to note any questions you might have. We will have a couple of minutes after the presentation to share. Yes, it's coming. So good luck and enjoy. Thank you.
Okay, thank you very much for this introduction. Hello to everybody and a warm welcome to all participants. I'm Stefan Sandner, as named before. I'm the CEO of Sherpa Mobile Robots, a French company based in Haguenau, 20 kilometers north of Strasbourg, for those people who are very good in geography. So it's in the northeast of France. And I have the pleasure today to present you some intralogistics solutions, use cases based on mobile robots. The core business of Sherpa Sherpa Mobile Robotics is the development, the manufacturing, and the deployment of autonomous mobile robots-based solutions. All our products are made in our French facility in north of Strasbourg. In each solution, you will find a high degree of safety and collaboration, as well in production logistics as in distribution logistics. Our goal is to always keep the human in the middle of our business or in the middle of each process and help them to interact with robots thanks to intuitive devices. In the following page, in videos, I will explain and demonstrate what collaboration of mobile robots with humans and machines means to Sherpa engineers and Sherpa company. Give me a second to load. So in the early stage of development, the main focus of Sherpa engineers was to set a full collaborative environment, not only on the AMR side, but also on the end user side, through a smart and easy to learn tool. The following video gives you an overview on how easy it is to use the tool suite of Sherpa Mobile Robotics. The Sherpa field engineers, when starting any installation at the customer site, begins the mapping with the following mode. As you have seen in the video at the beginning, the operator just took the robot with him. So the follow me mode is pick up the robots, take it with him and bring it to any operation and drive it through the alleys and record the map. So based on scanners on the robots, we can easily pick up the surroundings of the customer. After that, with very easy tools, the customer can program his routes, can program his zones, where he allows the automatic mobile robots to move and to drive. Here, for example, we have everything in green, show exactly where we allow the robot to drive. In red, we just drag in zones where the robot is not allowed to drive, where we forbid him to drive. So everything is very easy on graphical tools. Just pick any kinds of module, pick any kind of icon, a draw module, and then put in principally all behavior you would like to give to your installation. So it's very easy to use. There is no program line to code. Everything is done on a graphical mode. So customer doesn't need to have very good experts and very well trained experts in robotics or in software development to drive or to set up any installation. We have also measuring tools, and at the end, the road editor also gives some possibilities to put picks and drops points in order the robot can follow and can reach any destination in autonomous mode. The same easy drag and drop system will be used, in fact, to program the mission. So there is no need to drive again to set up any code line to program an installation. You just drag and drop the modules. You configure to the roadmap before any mission and any pick and drop missions. So the follow me mode and the full autonomous driving mode are standard functions on all Sherpa robots. The combination of both helps company to reduce pain, but also to increase productivity. The following video will show a real application in a motor, in an engine manufacturing facility in northeast of France. We will show you with five simple interaction between humans and robots how this cooperation is driven. So first of all, the worker picks up all his parts based on the follow me mode. So the robot follows him. He has a certain list of parts to pick in order to prepare the kit that will be sent later on to the assembly line. After this has been done, the robot drives to the final kitting station, where the operator also used the robot as a workbench to finish the process and to prepare the parts that will be ready to be assembled on the borderline. The third component is the full cooperation between operators on the assembly line and the robot itself. So the fourth function is the cooperation between robots and other robots on the line. So we have a full communication with other automated guided vehicle driving in this system. So we have here the example of full cooperation and collaboration between humans and between machines, as well as other driving vehicles. This was an example in the production lines, but our mobile robots find also a high acceptance in the distribution logistics and more in solutions for order preparation application in warehouses for B2B and B2C operations. Through an agile interface with customer WS or our smart picking solutions guides the operator and our mobile robots. Whether they both should do a common picking in follow me mode, or whether the operator has finished the picking in his own alley, he can send the robot to another alley, or the WMS automatically sends the robot to another alley to finish the picking or to consolidate some orders. This is all done by the same robot. So here we are in follow me mode, but later on we are also able to send the robot in full automatic to another station or to another operator. Here we have the Sherpa B for unit picking. We also have the Sherpa P for a pallet. These robots find the high acceptance in distribution for B2B. So as well as for the Sherpa B, the Sherpa P is following very smoothly the operator who can prepare his pallet, put the parts on the pallet. Even though he's driving in one direction or the other direction, the robot is always following him. Once his operation is complete, he can choose to send it back to any packing station or consolidation station or parking station where the pallet will be stored and picked up by another operator, picked up by another robot, or picked up or just dropped in front of a stretching or foiling installation. Through a powerful energy management and energy package we have on our robot, developed, by the way, in close cooperation with our today's host, thanks to them again, we can deploy large fleets and very competitive solutions due to a high level of availability. The palletizing solution we will see here goes exactly in the same way what we are developing. These large fleets allows us to complete here in this case a palletizing solution, and whether the palletizer is a human or it is a six-axis robot in full automatic, the Sherpa will have the same cooperation function as in each case. So we are bringing pallets, we are bringing goods, we are bringing boxes together on one position, and the Sherpa just keep the sequence in order to bring all these parts to the picker and also to pick them away and take them away. Okay, just give me a second. I need to pick up my presentation again. Okay. So to complete all these collaborative modes, Sherpa proposes a complete portfolio of mobile robots with numerous standards and certified tops. Whether they are to be integrated in production facilities or warehouses, they are fully operational when leaving our facility. The ISO 36991-4 appliance is validated on each specific robot, and CE certified is delivered by Sherpa. Again, through the powerful energy management, Sherpa is also proud to allow integrators to set up a specific top on the automatic mobile robots rolling base. You can see it here on a picture, for example, a cobot or any more complex conveyor system on a Sherpa B, where we have a maximum load of 1,000 kilo. So the fast opportunity battery charging we have in our portfolio and developed by Wiferion, and we are very proud to be part of this cooperation. helps us to enhance the availability of the robot using medium to high consuming tops. So energy is given, interlocks with safety stop is given on these robots, and communication is also there. So there's nothing to hold us back to do anything what is specific for the customer to put on the top of a rolling base. I reached the end of my presentation. The team of Sherpas is very happy that Wiferion has given us the opportunity to present our collaborative AMR solutions. Many thanks again to the team hosting this event. It was a pleasure to participate. Thank you very much. If you have more questions, don't hesitate to contact us or visit us in Magazino.
Stefan, thank you so much. And to everyone out there, hopefully my microphone is now in a better position than before and you can hear me clearly. Yeah, so thanks again. Very interesting, very great pictures. It's always good to see videos that things are already in place and not only prototypes or ideas. We are also very happy to have a close partnership with you guys. We are also very close friends and Freiburg, where Wiferion is located. So let's keep this up. I'm quite sure, Andreas, is the first time that you have seen Sherpa, as you mentioned. So maybe you have some questions. How is it?
Yeah. Let's talk a little bit about the follow me mode you actually referred to. I would like to know, why did you decided to have a follow me mode instead of an operator following the actual AGV or AMR?
I think it was in the early stage. In fact, the idea was born in 2015, and Sherpa is out of a company who's called Norcon, and it is very specialized in building picking cards for big customers in the e-commerce. And this customer came to Sherpa and say, hey, why do you provide us so much picking cards, and why couldn't you bring them to move? Why couldn't so the person does not need to push them? And then came this idea to say, okay, why not doing a robot who follows the people, so the human still the master where he wants to go, and the robot is just a stupid guy who follows it.
Very good. Thanks for that, Stefan. We have 2 more questions in the chat at the moment. I know you proceed with your system, the Sherpa. You can do in-process charging with the wireless charger from Wiferion. But the question is, how is the ratio of the robot between driving and charging?
So as we have the fast charging method, everybody who knows Wiferion, we can charge with an inductive mode of 16 amperes per hour. That's just huge. If we have on our robots 20 amperes, 21 amperes, so we have in 6 minutes we can, in 20 minutes we can do a full charge of a Sherpa B, and in 40 minutes a full charge of a Sherpa P. But we are not doing always full charges. We are doing opportunity charging, and so sometimes in 1 hour, I would say in average, we have 6 minutes where we are charging.
So you basically use every time, braking time, maybe stopping time during the process to instantly charge automatically a little bit of the energy into the battery, which is, I think, a very great concept. One more question. How fast can you develop new top configurations? You showed a couple of different applications on your Sherpa. So the question is, are you planning additional ones, and how long would it take to get new configurations?
To be honest, we are not a specialist to develop tops. We are specialists to give you a rolling base where any integrator can put a top on it. So it's not really our core business to develop tops. We do it because we have Norcon, which is our mother concern, who is able to do that. So I would say it's not our business. But for example, the tops you have seen, it was the tops we have seen in my pictures. It was for the cobot. It was more or less a study for a university. But the other one on the Sherpa B with the conveyors, it was about 2 months of development.
So I assume, Stefan, if someone comes and say, I want this robot with a new top and I'm going to order 1,000 pieces, you will be able to do it, right?
I would, yeah, I would say I will find the right integrator to do it. So I will be
Perfect.
ready to sell all the robots, but I can also give some good contacts with good integrators in the world.
Maybe one more question from my side, and maybe probably also the last one. Having the next speaker already sitting in the pole position, Stefan, if people are now interested in Sherpa, where would you say from your own perspective, where's your sweet spot? We have seen a couple of videos from production facilities. We have also seen a couple of warehousing things. Where do you see the benefits of Sherpa being the biggest?
I think the biggest in the future will be the warehouses. Yeah, we are very specialized in production, but production is more complex. But I think the most cooperative implementation or touch we have, I think it's in the warehouses. Yeah, a lot of warehouses are doing full automations. COVID has boosted all these full automatic warehouses, but I have a lot of customers that I meet. They say, I really want to keep my human in the middle of the process because humans can react to peak, yeah, and the full automatic process sometimes cannot respond to that, and the best response to peaks are humans. And with collaborative robots, it gives them more possibilities.
Yeah, great, Stefan. Thank you also for that answer. Please, everyone, understand we have a, let's say, very good timeline with a couple of other partners here to showcase as well. So any questions you might address into the chat box, we will definitely forward to the responsible or person of the partner, and we will be happy to forward it back later in order to answer your questions. So please, even if we cannot answer all questions today, we are sorry for that, but we you can be sure we're going to answer them after the event via an email contact. So thank you again, Stefan.
Thank you, Stefan. Great to meet you.
Thank you very much. It was a pleasure for me. Thank you.
Have a great day. Au revoir.
Thank you. Bye.
So the next one is Magazino, and actually it's a bit of a fun story because each time I see or read about Magazino, there's Soto and Toro being the main products, and I always mix them up. Knowing who's actually the ones carrying shoeboxes, who's the one being in an environment of production environments. So I'm hopefully happy to see that our next speaker, Lorenz, will provide some transparency here and explain again which robot does what, and has a great insight into the world of Magazino. Thank you, Lorenz.
Hi, welcome. Andreas. Hi, Julian. Thanks for the intro. I hope after the presentation, you know which one is Soto and which one is Toro. That's my main target for now.
Looking forward.
So, yeah. Hi, all. My name is Lorenz. I'm from Magazino. And then today I have the pleasure to present our solutions in the regards of the challenges of the intralogistics handling of boxes or totes. And yeah, maybe for the beginning, some words about Magazino. Magazino was founded as a startup already 8 years ago, and in the field of advanced robotics, so intelligent intralogistic robots. And Magazino was focusing not only of having a drive bus or kind of an HEV driving around, but also to have an active gripping system on the robot, as well as a storage system within the robot, which can transport several boxes at a time. So as Andreas already said, we have basically two products. We have the Toru, which is our robot for the shoebox handling. So whenever you're ordering shoes, maybe tonight online, then the chances are really high now that Toru is going to the shelf, picking the shoes and bringing it to a packing station. And our second robot is the robot Soto, which is our robot for which is focusing more on industrial products. So it was rather from the history, we started with Toru, and then people came up, hey, can't we use this a similar kind of robot, not only for shoes, but also in an industrial concept? Because people came up with several challenges on the industrial side. So there you have, if you have a close look on the transport of totes or KLTs, as we call it in Germany, due to the fact that the parts variance is getting higher and higher. Also the logistic effort is getting higher, while on the other side there is a focus also on lean logistics, and you have less and less space available. Next big point is also the cost pressure, and the focus on the savings, which after focusing on the production for a long time, the margin for any more saving was tight, and on the logistics side there is still a big margin for savings. When handling boxes, you can think about an average weight of a box of, let's say, 10 kilos. And if you do it all day long, and if a TUK trained driver is going to handle roughly 4.5 tons per day. So this is also a non-ergonomic job, which is in a field where we have a shortage of skilled workers, also a challenging task. And next big challenge for industrial companies was that if they want to go with innovations, they need to have the data available, which box is where at what time. And this they often didn't have available when having manual operations. So they were searching for a fully automatic end-to-end solution, bringing the boxes from the warehouse all the way directly to the assembly line. And in this context, Magazino developed the robot Soto, which you can see here. I'll just share a quick video. Just a second. Whoop. Where you can see Soto and one of our pilot customers. Here you can see Soto navigating in the industrial environment. We're navigating with SLAM algorithm. And then we are docking to a conveyor, which is resembling which is at the automatic warehouse. We are picking up the boxes, putting all boxes inside of our robot with a capacity of up to 24 boxes. Then we are navigating to the assembly line. And depending on the transport order, there might be several assembly stations where we are going to put down the boxes. We are docking to shelves. Then we grip the box again and putting it into the existing shelves or flow racks directly at the assembly line, where on the other side, the worker is standing and doing some assembly jobs. And as it's mostly a Kanban process, we can directly pick up the empty boxes again. From the gripping system, you can see here, we are going underneath the box, we lift it, and then we have conveyors to bring the box inside of our gripper, and then we put it inside our storage. And then the robot moves to the next shelf. So let me go back to the presentation. So let's have a close look on the functionalities and of the robot. So first, I'd like to explain the gripper in a little bit in more detail. So as you have seen in the video, the gripper is moving up and down to in heights of 0.4 to 1.7 meters, which is the most common heights you can see in the assembly area. The robot is open on 3 sides, so on the left, on the right, and also in the front. This is necessary to handle boxes also in narrow aisles where you cannot always dock in the certain orientation. The belt or the grippers, we are having belt grippers which can adjust automatically on the different sizes of the boxes. And on top of the robot, there is a clamp for the boxes. So if you imagine you're having a bigger box, 400 times 600, and this box should be delivered to an assembly or to a worker in a certain orientation for ergonomic gripping. Then we can clamp this box on top of our gripper. The gripper rotates underneath, and then it picks it up again and to deliver the box as it has to be on the assembly line. On the drive base, we are using omnidirectional drives. So we do not distinguish between driving forward, backward, sideward, in order to have a maximum maneuverability. The minimum aisle width we can drive in is 1.65 meters. And yeah, we have 3 safety scanners to ensure the safe operation next to employees. And additionally, as our robot is also rather high, and there's, as the classical industrial example, a forklift is parking there with a fork on 0.5 meter height. We can still see this kind of obstacle by having a 3D camera in the front and in the back of the robot. If you only have the laser scanners on the floor, you wouldn't be able to see obstacles like that. So furthermore, I'd like to focus on our internal storage, or we call it the backpack. This works like a flow rack, which can tilt to both sides, depending whether we are putting down a box inside the backpack or we are picking it up. So we always have 2 boxes behind each other within the backpack, and have here in the picture 4 layers, but in total we can have up to 6 layers in order to have a maximum capacity of 24 totes in the robot. From the totes themselves, we can handle the VDA standard sizes from 300 times 200 up to 600 times 400, and the weight is limited to 20 kilos. For interaction or interfaces, you've seen in the video the conveyors. So classically, we pick up at automatic warehouses where the boxes are coming out on a conveyor. There we pick the boxes up. Or we have a supermarket where we have flow racks, where you can also pick the boxes up and put them down. It's possible here to use existing shelves. What we need is a kind of a simple sheet metal adapter to ensure that the box is coming out in the front a little bit, so that we can grip the box with our conveyor grippers from underneath. And on the right-hand side, you can see what we have planned for the next year, or what is still in development, is an interaction between Soto and the Tucker train. So if you think about automotive industries, there are the distances are very far, and it doesn't make sense to have a complex robot like Soto driving all the way. Here's the concept of a shared supply. So a Tucker train or any other kind of HEV solution is transporting a huge number of boxes about along the huge distance, and then Soto is doing the fine handling or the last mile to bring the boxes completely into the assembly line shelves. On the process side, the process for Soto usually looks like this. There's a transport order coming from ERP or WMS system. Soto is driving to the warehouse or supermarket where the boxes are supplied on conveyors or in shelves. Soto is loading all the boxes within its order, then navigating through the assembly line and putting down the boxes directly into the shelves where the worker can pick them up. And in the meantime, when putting down a box, Soto can directly also pick up another box or an empty box to be returned to an empty station, and then the cycle begins from anew. Yeah, to come to the challenges we have seen in the beginning. So with the solution Soto, it's possible to have a complete end-to-end solution for the tote handling, or especially for for kind of replacing Tucker train operations. So if we have a look on the logistics, it's possible to deliver only 1 box, so you have more space available. You can have a just-in-time delivery, and you have a smooth delivery and a constant delivery. On the saving side, if we compare to a Tucker train operation, you can reduce the operational costs by up to 60%. And Soto, of course, can work 24/7. Coming back to the ergonomics, As you have seen, Soto can lift boxes up to 20 kilos. So you can also think about increasing the weight inside the boxes, as no human lifting of the boxes or handling is required anymore, and this ergonomic issue is avoided. And on the innovation side, whenever picking a box, we are scanning the box, so you have a constant tracking of the boxes, and you have constant access to the data where exactly your boxes are. And with Soto, you have the combination of the free navigation as well as the flexible handling system. You're putting down, picking up boxes in different heights on different sizes, etc. Yeah, so that's it from my side. I hope I could give you an overview, and I hope, Andreas, that you now know which one is the Toro and which one is the Soto of our robots. Thank you very much.
Thanks, Lorenz, for bringing transparency in who is Soto, who is Toro. Appreciate that, and I hope I finally can remember which robot does what. But maybe also a couple of questions in regards to the Soto. Where do we actually have the possibility to see the Soto in action? So if there's someone being interested, are there applications that you can actually show, or is it something where you say, yeah, come to Munich, come to our environment, and we show it in our test environment? What's the procedure?
Yeah, so for sure, you can always come to Munich. We have a demo room where you can see the robot running. But Soto is also running in some pilot projects, for example, at ZF Friedrichshafen or at the sensor manufacturer close to Freiburg in the Black Forest, Vega Grieshaber, where Soto is running in the pilot projects and where you can see it in an industrial environment, which I think is always more exciting and more challenging also for the robot.
Agree on that one. Maybe also grabbing a question from the chat, and also my personal question. And I remember I've asked it someone else from Magazino before. Why did you came up with the name Soto and Toro? What was it? This was some Japanese stuff or something like that. I don't remember exactly, but maybe you can enlighten us on that one to cut off the topic of the naming.
I only, similar to you, I only know this has something to do with, I think it's a Japanese translation for gripping or something like that. That's Soto, but I do not know for sure, but the naming has something to do with some Japanese vocabulary. I'm not familiar exactly.
Okay, Lorenz, let's put it this way. If you take part in the Intralogistics or the Future of Intralogistics Day 2 in autumn, we're gonna find that answer hopefully, yeah? So let's see. I have one more question in the chat, which was asked, maybe it's too technical, but coming away from the naming, the question was, what OmniDrive system is used at Soto? Are you able to share that, or is that something you need to basically buy first to find out?
No, I can share that. We are using omnidirectional drives from IBM Papst. So, and basically we're having two omnidirectional drives which are driven, and the other wheels are just more for stabilization of the robot. So 2 driven drives and 2 wheels for navigation, etc.
I have also one more question, which is, I mean, your system, it looks very innovative. And of course, it's also quite big because it has different layers in order to pick. How is it if you imagine you're running in a warehouse or in a production site and there's, let's say, interaction with other robots manufacturers or other AGVs, AMRs, you name it. Is that possible? And how do you cope with that challenge?
Yeah. So for sure, it's possible. So I mean, if we only have Soto running there and like let's say forklift and human operators, and then the complete control of the traffic, etc., is done by Magazino ourselves. If there are additional HEVs for pallet handling or any other kind of autonomous vehicles, then we can connect to any software, or we're supporting the VDA 5050 standard to connect to those higher level software, which gives us the rule and tells us when we can drive where in order to avoid any traffic jams, etc.
Maybe one last question before we head to the next guest. If you're interested as a logistics executive, how do you actually approach such a project with the Soto? You mentioned that you made some pilot projects with ZF, for instance. What's the typical approach? Is it something where you preferably start with a pilot and then scale up, or is that something where you go in with a big bang and say, here's your 10 Sotos, go for it?
So what we do is we usually start smaller, focusing on I mean, for sure you need to have a vision or a complete picture of the future, but usually we start with a smaller project with a limited number of robots, and then scaling up. So to have also a constant process, I think this a better approach for both sides, and with the limited risks.
Thank you for that, Lawrence. I would say that was a really interesting presentation. Thanks for enlightening us again on the naming as well as on the functionality of the Soto and what you guys at Magazino do. Much appreciated. Thank you.
Yeah,
Thank
you very
Lawrence.
much.
So that's actually a point where I have to say goodbye, Julian. I don't want to talk to
Goodbye.
you anymore. I'm going to replace you with another co-host, at least for this session. And I'm really happy to have finally a discussion also on site here in our little studio. And welcome, Tosja. Hi. Great to have you here, being the exchange for Julia now and being my counterpart for a discussion about mobile robots, about sensors and all that stuff. You are part of the executive board at SIG. I think most people in the intralogistics space have heard or at least have seen SIG. There's a color that actually typically everybody sees in adapted to conveyor technologies and sensors, which is light blue, I would say.
That's why I'm always wearing a blue suit, of course.
I saw that's the Hanseatic approach, but that's okay. Tosja, maybe you can start with a couple of words in regards to SIG, what you guys are actually doing also besides conveyor sensoric and all the stuff we're into.
Yes, of course. So first of all, thank you very much for inviting me to this fantastic event. I think very interesting conversation so far and presentations. So a few words about SIG. As you know, we're a family business with a little bit more than 11,000 employees, 2 billion in revenues. And the major focus is on sensor intelligence or sensor technology. And I think in this community, most people know SIG for the LiDAR technology, for let's say navigation, for security lasers and so on. But SIG, of course, has a very broad portfolio because we are also in, let's say, environment protection measurement technology and many other things. But today I'm here to really talk a little bit about the logistics challenges. And actually, I don't want to make a commercial for SIG today because I know a lot of you are using our products, but it's really talking more from the user perspective, what is important to SIG. Because as you know, I'm the Chief Operating Officer of SIG, meaning I have to deal with all the intralogistics and production challenges. Also, we have inside to produce our products. And I would like to share a few insights more about what are our requirements actually, for example, for AGV providers, for intralogistics providers, because I think that's what this is really about. So it's about giving you a user perspective rather than doing a sales commercial for our products.
That's great to hear. That's what we are all aiming for, right?
Exactly.
And hearing some insight. And it's really interesting to have this perspective from being a user, but also being someone who is trying to assist solutions. So I assume you guys are using AGVs in your warehouses. Maybe you can give a first background and sneak peek into this. How does the SIG warehouses and processes look like to get an understanding of where are you at?
Yes. So let me first start with where we stand right now. And I have to say, we still have a long way to go to full intralogistics automation. I think we've done so far a great job and a great focus, especially on our distribution models. And there we have a very high degree of automation. Within our production, we still have a lot of places where we work quite manually. Of course, we have several places where we do use AGVs in our intralogistics, but we are currently really evaluating the full process of intralogistics at SIG. because as you can imagine, we have a very complex product portfolio. We have very small products, high-tech products, we have very large products. And that, of course, is a big challenge, especially for our intralogistics. And we have hundreds, thousands of components we have to deliver to our production lines. And these components are very different from mechanical parts, big parts, heavy parts, small parts, electronic components. So we have a very broad internal manufacturing with very different manufacturing capabilities from CNC manufacturing, SMD production, and many others. And as you can imagine, that includes a lot of processes in order to provide our lines with the necessary material. And I would say the biggest challenge I currently see is really the complexity of material we have to handle and we have to bring to our production lines and from our production lines. And the automation is not that simple as you might think in the first place, because it's so diverse, it's so broad. And the most important aspect for me is that we really need a system which is extremely flexible, because we will have that very broad range of material transport and processes. And that's actually why we are looking very much for the, let's say, ability to integrate the technology in a very broad and flexible way in our production sites. And as you know, we have a very modern production site here, close to here in Hochdorf, our so-called next-gen operations. And there we are already fully doing the intralogistics transport based on AGVs. But we have other sites where we're using other AGVs or where we don't have any automation.
When we talk about the challenges, and especially the challenges of having a very diverse environment and different aspects of the production and how you actually handle the material flow, do you believe the challenge is more on a hardware level or more on a software level?
I'm really honest here. I think the challenge is really on the software side. And what for us as a user is the most important is the interoperability between different systems. It's very clear that we will need a broad range of different hardware systems in order to do the broad range of tasks we have to fulfill. And that is meaning, and that's actually something I'm all asking you for, to really work on a system which has open standards, open connectivity. I know this is difficult because different competitors have to work together in an open, let's say, economic environment, because otherwise for us as a user, it will be very difficult to find the right system, because it's very sure we will use different hardware for different applications. And that means we also have to deal with different providers for AGVs, for example. And that means we need a system we can integrate in our software environment, in our processes in a very easy way. So interoperability, standardization, I think is a really important topic.
What's the key from your perspective here? Is it like industrial standards, as we have heard also from Magazino with the VDA 5050, to have like a standard integration net framework, I would say, to actually integrate different hardware aspects? Or is it something I say, maybe that's not the right thing? Maybe it's like open source or whatever comes to your mind?
You know, the open source model, I think, has been proven to be extremely powerful. But on the other hand, we always have to look for an economic system that is attractive to everyone. So what I would expect is that it's really more about a standardization, and then all the hardware providers, the system providers can really use this, let's say, that standard APIs to integrate their systems. What is important is that this can be done with minimum efforts, quickly, because we don't have the time, for example, to integrate a system over a period of 6, 9, 12 months. This has to be much faster and simpler.
How long is much faster from your perspective? What would you aim for?
Well, of course, what would I like to see is, and that's of course only a dream. I know it's not maybe completely realistic, but it's really to go to look for an application, a certain process, and then we can take this or that hardware and integrate it, let's say, within a period of 6 weeks in order to be able to automate that process. I mean, that's not realistic in the moment, but I think for the future, it might be possible if there is that kind of, let's say, industry standard which everybody applies to.
So you also see software being the obstacle of having fast integrations, not necessarily the hardware part with all the mapping of environments and all that stuff that you typically do?
Of course, I think both aspects are very challenging. Let's face it, it's not a simple task of doing it. I'm certainly not saying that. The software layer, I still think, is the more complex part, because you, as an AGV provider company, you will find like hundreds of different software environments into which you have to integrate. And if I just look at the software landscape we have at SIG, it's certainly complex, and we are developing our, let's say, for example, manufacturing execution system. At the moment, we are changing the software. We have to switch, let's say, for example, to S/4HANA. We have to integrate a new executive warehouse management, and so on and so on. So it's a changing environment, and that makes it even more, let's say, challenging for the integration.
Talking about wishes before, would you wish for a one-fits-all system, saying that's all done in SAP and I'm gone? Or are you realistic enough to say probably not going to happen?
No, it's not going to happen. And what I have to say, for example, we have tasks where I would even guess that a train-based system might be the right application. Some of you have heard of the servo system, or other companies have that kind of systems. And then there are tasks which are certainly not suitable for such a system, but where we really need an AGV. And let's face it, we will need different systems for different applications. And that's absolutely okay for me. I think it's, in the end, we will see a hybrid system, which then can fulfill more or less all the tasks we have in operations.
Yeah. Interesting aspects on the software bit. Coming a bit also on the challenges in regards to hardware. Where do you see the biggest problems, if there are any, in regards to the actual hardware of the AGVs?
What is the biggest challenge there? Of course, it's really, if you have the different applications, you always need, let's say, the different handling system. And I think what will be interesting for us to have kind of a standard handling system for certain applications. Hardware-wise, we can then connect, for example, to our automated warehouse. So it's really then about the interfaces, the points where you have to transfer the production material from one side to the other, for example, from the AGV to the Kanban system, and so on. So that will be the interesting part. The other thing I really would like to mention, what is a big challenge for me, is really we want to save space in production. Production space is really expensive, and that means we think a lot about just in sequence support of our production lines to avoid having too much material on the lines. That's one aspect. The second aspect I have, and that's about the speed, where I see that sometimes the AGVs might not be fast enough at the moment, is that we need a very high flexibility on the line, because also our customers require different types of products, and we try to make our manufacturing more and more flexible. That's Industry 4.0, customization, one-piece flow, and so on. And that, of course, requires that we also integrate that into the Intralogistics. And that, for me, is another big challenge.
I think that's a tough challenge, to be honest. I think many people are not necessarily looking at the first shot when automizing material flows. They're not necessarily looking at first into just in sequence, just in time, all that complicated stuff we know from automotive and whatever, from production environments. I believe that's probably not the first focus area, right?
That's correct.
That's an issue, isn't it? I mean, it would be great for you to get solutions in place fast, but the market isn't ready really for this, or?
Yes, I certainly would agree to that. So it's a stepwise development, and what I really like, coming also back to what SIG is doing. Right now, we are developing our products together with our customers, like, for example, the AGV providers. So we get a lot of input also for our products, and the same, I think, we have to do vice versa, is really working with the supplier together and finding the right solution for certain processes. And let's face it, there are hundreds, thousands of processes, and for each process, you might need slightly different hardware, software, and so on. And I think we, as a customer, as a user, have to be open to develop these kind of systems together with the AGV providers.
Is that the approach you see as the identity also, maybe a little bit of SIG, saying, okay, we are looking into like an ecosystem and collaborative working with vendors, startups, suppliers from different spheres?
Yes. So, I mean, especially if you look at our LiDAR business portfolio, product portfolio, it's a lot of that is developed, and especially the software around that is developed together with customers. And we need that open ecosystems in order to really get to fast and viable solution. And especially we all have to take that, let's say, minimum viable product approach, agile development approach to get to fast solutions. And that means everybody in the ecosystem has to be really open for cooperation, because nobody can do it alone.
Is that easy for an 11,000 people business?
That's a very good question. I mean, I hope we are still, in a sense, acting sometimes as a startup, as a company. For sure, yes, we have our processes, and for sure, it's not so easy for such a big company always doing that. But I think we have very good approaches. And for example, we also have internal startups, because we realized we have to be extremely open, flexible, fast in the way we are working. And that agile development process is something we really focus on a lot.
Which is at the end probably also a capability that makes the difference, right? Towards the other companies, towards competition, towards the market, and being ahead of the business actually, and actually having a leading role. Maybe a more general question, coming also soon to the end. Do you believe that AGVs are the future of intralogistics, as the event is called today?
Yes, for sure. I'm absolutely sure they will have their very important, very safe place in intralogistics. But as I said, I believe that we will see hybrid system depending on the type of production we have we have to serve with the intralogistics. But for sure, without that, I couldn't even imagine becoming a, let's say, modern Industry 4.0 company. It's essential.
Yeah. Looking forward for that. What was actually the intention, and when did you actually realize that AGVs are a thing, and to hop into that market and say, we need to be a part of this, coming from the traditional conveyor world and less flexibility, if you want to.
Well, to be honest, I think SICK is in LiDAR technology since so many years, and was obvious that this is one of the most interesting applications. And I think also it's one of the most interesting markets at the moment, because it's very quickly growing, and it's out of question. We had to focus on that market immediately.
Also grabbing a question from the audience here. How is the market in regards to AMRs different than the other environments? Is it the dynamic of constant development, because there's companies popping up, from my guess, every day there's new solution providers in the market? Is that the dynamic in the market that has the most difference?
I would believe so, yes. And indeed, also for us as a company, it's sometimes difficult to pick the right partners, because there are so many startups available at the moment working on different applications. And of course, as I said before, if we have that open ecosystem, and also we have to provide a lot of efforts into these projects, it's really important that we don't take every application which is possible. And I think there are applications which make more sense, and some which make probably less sense. So we really have to look also for the business case in the end. And that's maybe another interesting aspect. Today, if I look at the use cases we have, it's not always obvious we have immediately a good business case behind. We still decide to do it also in our internal intralogistics, because we want to learn, and we want to get to the point where it really becomes very economic.
Sounds really, really interesting. And at this point of time, I would say thank you very much, Torsten. That was a really, really interesting discussion, and I have the feeling that we could take this forever. But let's take a couple of questions also still from the audience, and not letting them flow around. So one question is, how is this one we answered? What are the biggest sensor trends in intralogistics? That's, of course, we agreed that we don't want to discuss too much about SICK itself, but still, there's the interest, there's the logo.
Honestly, I think answer that independent of SICK. So what I think it's really about, let's say, secure or safety sensors, because what really brings the speed? The speed is brought if the sensor is fast enough and accurate enough to really slow down an application or speed it up immediately if there's, for example, some intervention with the operating field of the AGV. So I think that's a trend to save sensors which is important if you want to keep up with the speed. Today, for example, if you have a robot in manufacturing, typically you have a fence around it so that nobody enters that production space, but we will see much more collaborative automation in the future. And for that, of course, you need sensors which are able to, let's say, lead to a secure environment for that type of collaboration. We have that all the time in intralogistics because the AGVs are running in the production sites and they have to run fast and secure, and safety for me is a really important topic there.
That's actually leading pretty well to the next question from the audience, saying what is the major safety challenge in AGVs? And a question I personally love to read, is it different for AGVs and AMRs? Where's actually a difference?
Well, is it different? That depends really more on the application, I would say, because in production logistics, you could always, let's say, have certain standard routes, times, and so on. I think it's easier to steer it. If you have, for example, a cleaning robot, which is running at the airport where you have, let's say, a much less predictive environment, safety is becoming more important. And also, the whole, let's say, safety infrastructure of the AMR AGV has to be faster and more secure. So it really depends on the type of application, I would say.
Interesting. Tosja, before we end up talking the whole day and disturbing your whole time, I would say thank you for that. I would prefer to exchange you now again to Julian, not because I don't enjoy the conversation, but we need to hurry up with the agenda. That's how it is with a dense day. But thank you very much for that interesting insights.
Thank you very much for inviting me.
You're welcome. Welcome back, Julian.
Welcome.
Great.
Amazing. I have a little break. I'm back and very excited about our next speaker.
I hope you slept well in your little break, had a drink, had some food. So the next guest is actually Safelog. So welcome, Rick. Are you already here with us in our digital studio?
Rick, can you hear us?
Not yet, though.
There he is.
At least he's there.
We can see you, so you cannot hide. Maybe you can give a little introduction about Safelog.
Yeah, I'm pretty sure there's some overlapping between the discussions we had and the challenges we discussed with Zig, and the challenges Zig is trying to solve. Probably similar questions Safelog is trying to solve, just from a different angle, right? And here I see at least that I can at least see Rick. Hi, Rick.
Now, yeah, finally.
There you are.
There he is. Welcome.
Yeah,
Glad
hello.
to see you. The stage is yours, I would say.
Yes, enjoy it. 20 minutes fame.
Hello and good afternoon. Welcome to the Safelog headquarters in Marktschwaben. My name is Alex Strunz, and today I'm talking to Rick Lübgens about the future of intralogistics and an interesting AGV project in Innsbruck, Austria. Hi Rick. As already mentioned in the live introduction, you are head of business development and sales at Safelog. Therefore, you're well informed about trends in intralogistics and future innovative solutions. What are the main topics in the field of logistics process automation that you're asked about by your customers?
Hi Alex, the automation of processes has already been a big topic in the intralogistics for several years. Smart factory and, for example, IoT are just some buzzwords here. What is new is that the need for automation is not only driven by financial aspects anymore. What I've noticed in many customers' meetings is that you must automate now just because you don't find the people anymore who are willing to do the jobs in the logistic or in your warehouse.
Are there any specific sectors that are affected by this?
No, this is actually evident across all industries. Regardless of whether it's a classic medium-sized manufacturer or an operator of logistic warehouses or a classic online retailer. Meanwhile, in each industry, there are attempts to automate, for example, transport tasks or picking tasks, just to get your daily business done and to focus on other topics which are way more important, probably.
Oh, okay. And what are the biggest problems, or let's say, what are the biggest challenges in automating these transport tasks?
That's a good question. Well, basically what I faced with many new customers, especially with customers who are inexperienced with automating of their processes and their, is that basically they have too high expectations. They are influenced by nice-looking marketing YouTube videos or on LinkedIn marketing videos, and they expect, for example, that the new technology works like plug and play. You know, that you just throw them into your factory and they start working. But this isn't true. The true is much more, boring often. You know, if you don't focus, for example, the main important thing, for example, are the safety aspects, you know, and this is a very boring topic, and especially especially people who are not don't have the experience, often don't focus on this topic, but it is the most important topic, for example. And the second most important thing is the stability. In terms of technical availability. If, for example, the system stops every 2 hours and your technicians are not capable to handle this new technology, and to bring the system back to operation, then this new technology will fail.
With this know-how, Safelog has already developed and successfully implemented such solutions. Do you have an example for us?
Yes, of course. For example, 2 years ago, we were approached by PohlCube, an online retailer for sporting goods, who needed a new automated goods-to-person solution for his new logistics center. In contrast to the previous classic warehouse, most parts of the storage and retrieval activities, as well as the order picking, are now automated.
And what was the reason why PohlCube decided to automate these activities with transport vehicles or transport robots?
Well, as mentioned before, one reason was the lack of people who are willing to do this job. You don't find them anymore. Well, one reason for that is probably that the pickers in a classical warehouse have to walk over 25 kilometers per day or more, and this is also a very time and cost-consuming aspect which has to be reduced. Well, also in this context, ergonomics also play a huge role, which occur when picking heavy products or moving the picking trolley, for example.
And Rick, which Safelog solutions were used to realize the customer's wishes?
Well, the small items coming out of the AutoStore pickboards are dropped directly in one of the 18 small mobile robots by Safelog. These are equipped with special designed transport boxes. Once all products have been picked, the picker sends the HV afterwards to the automated packing station.
Okay.
The large items are stocked in a total of 500 shelves in the basement. If an article is needed, one of the 10 mobile robots drives to the respective storage location, drives under the shelf and lifts it out. Afterward, the mobile robot brings the shelf to the order picker on the ground, and after the pick has been completed, the shelf is automatically returned to the basement by the mobile robot again.
Can the positive effects of PohlCube also be expressed in figures?
Yes, actually it can. For example, the process speed of the picking process was increased tremendously, so that over 3,000 orders can be handled by only 2 pickers. And in the same time, the probability of errors in the picking process has been reduced to almost 0. And also the distance the pickers have to travel every day was reduced significantly by 80% with this solution.
Oh, perfect. That sounds like a very complex and interesting project. To give us a better idea, you filmed a video with the owner of Sport OK, which you brought along for us to illustrate. At this point, thank you very much so far, Rick. I would like to say goodbye and hope you enjoy your trip to Sport OK in Innsbruck and the subsequent Q&A session with Rick. Goodbye and have a nice day.
Thank you very much and have a lot of fun with the film.
Wir sind hier im Logistikzentrum von Sport OK.com im Herzen der Alpen in Innsbruck. Konrad Blankensteiner, ich bin CEO und Mitgründer von SportOK.com.
Das Besondere an diesem Standort von Sport OK ist, dass wir hier uns eigentlich in der Innenstadt von Innsbruck befinden und dadurch ergeben sich natürlich gewisse bauliche Restriktionen.
Daher haben wir unseren Lagerstandort sehr hoch gebaut und in die Erde tief hinunter, sodass wir ein Maximum an Raumvolumina nutzen können.
Im Keller wird eingelagert, im Erdgeschoss wird kommissioniert. Die Herausforderung ist dann natürlich, dass wir in eine Art Konsolenheber einfahren müssen, der die HGVs vom Kellergeschoss ins Erdgeschoss bringt und dann nach der Kommissionierung wieder nach unten verbringt.
Die zweite Anforderung ist bei uns, dass wir hier diese Produkte automatisiert auf freier Fläche von Pickstationen zu den Verpackungsstationen bringen, wo diese Produkte dann hochautomatisiert mit Verpackungsrobotern verpackt werden.
Wir verwenden ein hybrides Navigationssystem. Das heißt, dass wir nicht nur einen Navigationslayer haben, sondern mehrere. Das hat einfach damit zu tun, dass wir einen besonderen Wert auf die Stabilität der Prozesse legen.
Mit Einführung von Safelog-Robotern ist es gelungen, dass wir hier de facto 0 Fehlerrate haben und das wirkt sich natürlich auch sehr in der Kundenzufriedenheit aus. Die Safelog-Lösungen sind für uns ein wesentlicher Bestandteil in der Automatisierung, weil wir hier sehr schnell auch ein Wachstum von 50 oder 100% bewältigen können. Safelog bedeutet für mich Bodenständigkeit, höchste technologische Qualität und auch Flexibilität.
So.
Yeah, Rick, thank you. Very impressive video. I really liked it.
Yeah, thank you very much. I started it a little bit abruptly, but it's okay.
No, everything good. I think it's important to deliver the content, and you definitely made it happen. Very nice presentation idea with the interview together with Alexander Strunz and you. Very well done, and very interesting to see how also, let's say, completely different systems away from production lines in the warehouse at Sports OK have realized the solution. I think it was a good combination. Yeah, surprisingly with an auto store concept, as far as I know. So
Yeah.
it's a coincidence. Yeah, maybe you can also help us with some of the questions which are already coming into the chat. So I think at Sport OK, the question what I would have is it, let's say, a project you can easily copy to somewhere else? Is it some kind of a blueprint, or how would you see that project at Sport OK?
Well, basically, you can also use it for other customers as well, of course. Well, in principle, the products only must fit into the shelves, and must not exceed a weight of 1.5 tons. And then the system can be used for any customer in each industry, which is pretty cool.
I think it's really interesting to see, right? So typically you see applications with mobile robots that are more transport from A to B, and this is some kind of transport, but it's also goods to person, which is like an additional feature, isn't it?
Absolutely. And the funny thing about the SportOK application is that the small parts were done or are picked and stored in the auto store, and the big parts like skis or something are stored and picked by our system.
Yeah,
So
you can also see
both. Yeah.
in the video you really saw the narrow aisle your system is driving, and also with the racks on top. So how difficult, or how do you do basically that the Safelog AGV is precisely navigating under the racks? So is there a special technique you use, or if you can, let us know the secret.
Well, basically, there is not only just one technique for it. We use various number of techniques. One solution is, for example, RFID tags, which are attached to the shelves. The other one is light sensors, which detect exactly the position and of the shelves. And if necessary, the HGV can also reposition itself underneath the shelf.
Okay. I think the question in the chat is also a little bit attached to that. The video talked about several navigation layers, but AMR seems to have only one laser scanner. How does this work?
Well, basically, we not only have one laser sensor, or we not only use one laser sensor for our navigation, we have a hybrid navigation. And this means that we not only use one layer. One layer is, for example, the safety scanner. Yes, that's correct, which detects the environment. And the other layer, or navigation layer we are using is, for example, can be, if necessary, a magnetic stripe on the floor. Another option can also be cameras, which we attached, and the cameras detect the environment and detect, for example, Aruco markers in the environment, and then we know exactly our position. And also another positioning system is, or navigation system is, the speed of each motor, and can be measured, and from this point you can calculate back how far you traveled. And there is the most important thing is stability, to bring stability in the process. And so I always recommend not only focus and use just one navigation layer. We have very good experience by using several navigation layers and bring them together and add them, and yes, have the best out of them all together.
Yeah, sounds reasonable. Maybe a question also from my side, Greg. The solution at SportOK, is that a collaborative model, or is that something which you typically see on the goods-to-person AMR solutions, where you actually have like a framed or caged environment? I mean, in this specific case, it was like the lower level of the building, taking the lift to an upper level, but is it then collaborative on the picking level, or is it fenced?
No, it's collaborative. The HVs or AMRs we are using have safety sensors, and so basically, if necessary, the technician can easily step into the warehouse without stopping the whole system, which is very helpful sometimes.
One more question, because apparently that video is very interesting for our guests and also for us. The question is, has SportOK involved the solution in one step, or was it an incremental? So means a step-by-step approach to place this solution.
Well, basically it was a step-by-step approach, because SportOK itself is more or less a startup, and it started very small as a company, and also as the requirements were smaller when we met 3 years ago. And as the company grows, although the requirements for the picking or the orders increased, which means that also that our systems also have to be increased, and new HVs has to be implemented to the system.
Really, really interesting solution in this specific example. So thanks for sharing transparency on the Sports OK site, which is also, from my personal experience, as Jürgen already said, it's a really impressive site. So I can recommend to visit the site and to watch the video again. Really interesting approach there in Innsbruck. Rick, maybe also looking a bit ahead of what you've done at Sports OK. What's in the development pipeline for Safelog? What are the new products? As far as I remember, not being the HGV expert myself, but as far as I remember, there has been a recent product release from Safelog or something like that.
Yes, there are some exciting new products in the development pipeline. One is our new HGV X1, which is particularly suitable for goods-to-man applications. What you saw now in the Sport OK video was actually not the X1 HGV, it was our L1 HGV, which is also applicable for this application, but the X1 is even better. And also price-wise, especially price-wise. The other new product is our new HGV with lifting unit. And you can drive now under pallets and lift up to 1,000 tons. And the special thing about this HGV is that it only has a height of 200 millimeters. So even very flat trolleys can be driven under.
Wow.
So we will be able to see it, I guess, on a Logimat. Is that the day to show and stop by at the Safelog booth?
That's the plan, and I hope our suppliers won't let us down. I don't know.
Let's put it this way. As Wiferion is one of your suppliers, we will not let you down, I promise you. And by the way, if you stop by at the Safelog booth, just across the Safelog booth at Logimat, you will coincidentally find Wiferion booth.
Surprise.
So, surprise. Let's put a little bit of self-commercial in here. So Rick, thank you so much.
Thank you. Really,
Very
really
cool
interesting.
presentation and impressive. Good luck for your company and the development. I really see bright future here. Thank you.
Thank you, Rick. See you then.
Thank you. Bye.
So bringing us to the next guest. I think the bar is pretty high now. So this was a really impressive video. Great preparation. So the next guest is Dennis, coming from PohlCon. Dennis, are you with us already?
Hello, my name is Dennis Thieler. I'm the Manager Innovation and New Business working for PohlCon. PohlCon is a manufacturer in the building product sector and is represented worldwide with branches and production plants. We are a solution provider in 7 fields of application with in total 10 product categories. And today I'm going to talk about one solution in the material handling field. When we talk about how the future of logistics could look like, the deployment of AGVs and AMRs plays an outstanding role here. In this context, it is also important to think about how the right charging infrastructure can support the goals of automation projects. Same for the productivity of robotic fleets. How does the current situation look like? So we have situations where charging equipment is placed on the ground or ground level when, for example, a conductive-based vehicle charging approach is used. We have other situations where a cable-based charging procedure is required, for example, to charge a forklift's battery. Those charging areas are often marked as restricted areas. And when you think about already existing buildings, the search for free space for such areas is often problematic and not easy to balance the different stakeholders. The disadvantages we see here are that charging zones occupy areas which could be used for more efficient space utilization. Another point to mention is that on-ground charging zones are causing detours for robots, staff members or other vehicles. Furthermore, on-ground charging equipment may face a high risk of damage or wear when you think of indoor traffic-related topics, for example cross-traffic events or just carelessness. Another topic is the safety at work when we consider on-ground charging equipment as a potential tripping hazard or as a little barrier for the environment. However, the biggest issue we see here is that charging zones are in a lot of cases outside the working cycle. This means unproductive off time for AGVs in order to charge the battery, and the need of compensation by the remaining HGV fleet. The overall fleet productivity is therefore in many cases below the true potential. However, we believe that fleet energy management should be alongside the HGV routes and has to be seen as a part of the working process to avoid off-time. We also believe that the charging process should be embedded in the environment as discreet as possible. And of course, that charging infrastructure should not interfere in any way with employee or other vehicles' workflows. To sum this up, we are firmly convinced that the continuous operations of HGVs needs a truly integrated charging approach, and the right technology for us is here the wireless charging technology. From our point of view, the approach of using an in-ground wireless charging infrastructure adds a lot of value to the logistic and production processes. It increases the efficiency of the fleet and supports the building utilization. In this described context, we developed an infrastructure product which is a true enabler for the wireless charging technology, especially for the Wiferion Etalink 3000. Our solution is the Wireless Charging Protection System, or short WCPS. It offers tremendous benefits and closes the planning gap between an efficient fleet utilization, an efficient energy supply, and the need of a process-integrated charging strategy. The idea is quite simple. Charging the robot during the day and as a part of the process increases the productivity of the whole fleet with a reasonable number of robots. The main advantages of our solution are that the WCPS system is integrated seamlessly into the ground and is fully harmonized with Wifirion's Etalink 3000 in order to allow opportunity charging. It is suitable for all kinds of production and logistic areas. It leads to maximal flexible space utilization with no blocked areas. Different vehicles can share the same charging spot. Vehicles can also drive over it. No bypass routes or risk of trip hazards. Optimal protection of the high-tech charging electronics and cable. So, following the concept of in-process charging, WCPS and Etalink is a perfect combination for modern material handling environments. When planning an automation project with HGVs or AMRs, you should consider the charging management in an early phase. Following the idea of an embedded in-process charging approach, we strongly recommend to plan with a wireless charging technology and our WCPS infrastructure product in order to exploit the full potential of your fleet's productivity and to increase the overall flexibility of your automation project. For all of your planning questions, installation or other operative topics, we are happy to support you here. Thanks for your attention.
More and more coming up is a good point, Andreas.
Wow.
What's coming up? Yeah, we are looking forward to the company Identpro. Join the digital intralogistics. No HGV AMR without digitalization. Your warehouse first. I think that's a very good title because it's open. And I mean, you're the experts in digitalization and optimization as a consultant. What do you think we can expect?
I think that's a statement probably everybody would agree on without knowing what's behind it. So really looking forward and welcome.
Hello?
Benedict here. Hi, Benedict.
We can hear you.
I cannot hear you.
Okay, but we can hear you.
That's at least something.
Yeah.
So now we have the other way around. The first session, the session before, we had some audio problems into our direction. Now it's from our direction. Looking forward to have this fixed.
So
now you unplugged your microphone. That's exactly not what we would prefer to do. The other way around was better. I prefer to hear you instead of you hearing us, to be really honest. So Benedict, are you with us already?
Can you hear us now? We can see and hear you. We cannot hear you anymore. Yeah, suddenly the first 3 presentations run so smooth. Maybe now it's time to get some...
I think it would be boring to have a day without any issues. And to be really honest, we are not a professional video studio here. We have a dedicated environment that's pretty decent. And we have professionals sitting behind the screens. No negative vibes here. But it's always how it is. That's how it is with online events, and that's how it is. But we can discuss a little bit on digitalization of your warehouse first. And I think the discussion itself fits pretty well to what we discussed also with Thorsten. There you are.
Yes.
Welcome, Benedict.
Nice to see you and nice to hear you.
Okay, we can hear you very well. Yes.
We can hear you very well and loud.
Good.
So the stage is yours without discussing from our side too much, feel free, shoot.
Okay, so 1 second. So I hope you see my presentation mode. Hello?
Yes, we can hear. We can
Yes,
see and
we could see
hear
you.
Okay. So a bit strange today. Yesterday it was better. Okay, so yeah, welcome to everybody to the presentation of Identpro. So first I would like to introduce myself. My name is Benedikt. I am sales engineer at Identpro. Identpro is a German company which is based in Troisdorf in the near of Cologne. Today we want to present details of using AMRs or AGVs in intralogistics and also in combination to a manned fleet with our warehouse execution system. So you see the title of our presentation, No AGV AMR Without Digitalizing Your Warehouse First. I would like to explain why we defend this view. So first of all, let's start with a short exercise. If you Google warehouse efficiency, you will find a few results, and most of them are showing automatizations in warehouse. So that means if we are talking about efficiency gains and if we are talking about optimization in intralogistics and warehouses, the majority of interest and the publication of information is about automatization and robots being used for exchange manual work to automatic work. So the scope of many customers is to be more independent from human resources. And if we go a little bit more in detail and we have a look in our inquiries in 2022, we see the same trend and the same picture in our inquiries. So the next slide shows you our inquiries so far in 2022. And basically we see that nearly 70% of the requests are regarding warehouse robotics, and just 30% are regarding general warehouse optimization and efficiency gains. And if we go a bit more detail now, you see that half of these requests are not digitalized at all. So that means these customers does not have a connection to upper ERP or WMS system. And for these customers, the first step into efficiency gains would be the AMR or AGV. So what we also see within that inquiries is that 80% of them are looking for just an isolated solution, transport from A to B. So, for example, a transport from a production source to a defined position in the warehouse. And this is really simple because the potential customer, they understood that a connection to the WMS system could be a complexity which most of them could not fulfill. Now I would like to share some use case from our warehouse execution system. And the first use case is a typical use case of implementing an AMR in a simple process from A to B. So at this customer, we have a production belt where a new finished good pallet is ready to collect, and we are connected to that conveyor belt. So we know that there is a pallet, and then we are searching with a stocking strategy for a free empty spot in the warehouse. So the unload position is in a block storage cell. So that means we decide where has the pallet to be placed and stored. So we create a transport order and give that transport order to that LGV. So when you see a short video now, that means you will see that the AMR picked up that pallet. He has to relift it because he has to make sure that the heaviest point of the pallet is close to the end of the forks. And now the vehicle is on the way to that block storage cell and unload the pallet at the final destination. So what we have in this use case now, we implemented 3 AMRs in a 24/7 scenery. And for sure that makes sense for the customer because the scope of them was to eliminate each manual work in that process. So, and we were able within that project to reduce 5 to 6 workers. That brings a return on invest of 1.5 years for the customer. So it was easy to calculate. So now I would like to explain our AMR, which we provide. So we have different types with also different payloads and lift heights. In that picture, you see the vehicle Linde L16 AP. So basically, we buy these vehicles at Linde, but we do the assembly of different kind of sensors on it. So we have a localization with LiDAR, so that brings the exact position of the vehicle. We also use this LiDAR technology at the implementing on the manned fleet. So we see that in the next use case. So we have a good recognition. That means that we see the entering spots on a pallet. With that goods recognition, we are able to see if the pallet is not in a straight direction. So we can adjust the direction and we pick up the pallet then. So we have an obstacle recognition and we have also a different battery technology, a lithium-ion battery, and we are using a charging system without wires and contacts. So thank you very much to Wiferion. And with these updates, we are able to run the vehicle completely autonomously and independently. So we are braking it, we are steering it, the vehicle does not need a certain way. It finds its way on its own. It figures out if there's an obstacle or not. It stops if there's an obstacle, and it starts moving if the obstacle has left. So it can work completely independently, and that's the reason why we call it as an AMR and not an AGV. Coming back to the title, no AGV AMR without digitalizing warehouse first. So sure, you can do this first step with a simple transport from A to B, but at the end, this customer was looking for a solution how we can move forward within that warehouse. So he was looking for a solution to bring the pallets scan-free out of the warehouse, to load the trucks with the needed goods. So, and from our point of view, this is a logistical process which is currently not able to be done with robots in a robustly 24/7 scenario. So this customer decides to do this with manual trucks. That means normally if you use manual trucks to load this trucks, these lorries, you need hand scanners to find and confirm the picked goods which are needed for the delivery list. And this is not really efficient, and this does occur a high failure potential. So what we did for that customer, we use our warehouse execution system for the manned fleet as well. So we create a digital twin for each pallet, and we already did that in the first stage. So we have the exact coordinate XYZ where we unload the pallets in the block storage. And now we equipped the manned fleet with some sensors. So we also have that LiDAR sensor for the exact positioning. We have IoT sensors for the automatical load detection and height. We have a terminal which can communicate and address doings and tasks to the driver. And at the end, our warehouse execution system at that manned fleet has an automatical digital track and trace. So it is connected to the WMS system. And if we now get a transport order or delivery list, we address that to a driver and helps him to pick up the right goods. We mapping the right articles in our map, and so we make then sure that the driver can do a scan-free and a loading of the truck without any mistakes. And that's all then controlled by our warehouse execution server. So the complete warehouse setting for that customer is digitalized with the AMRs and the manned fleet. And this brings some savings for the customer. So we could increase the efficiency up to 20%, and we have a complete transparency and traceability of all the warehouse movements. So within the next use case, I show you the opposite way around. So that means that for this customer, the customer expects the solution to have a complete scan-free and 100% digitalized warehouse. And at this customer, we also equipped our sensors on the manned fleet. We are in connection to the leading WMS system. And what we did in the first stage, we digitalized the complete warehouse. So that means all manned forklifts are equipped, and all the pallets which are in the warehouse are completely known within their exact XYZ position. And we do the complete tracking scan-free, and we do the complete truck loadings. So we have 100 trucks per day without any scan and without any mistake. So that brings, in that first stage, savings to the customer. So we have a reduction of 4 FTEs, and we have an increase of the efficiency up to 20%, because it is not necessary to scan, it is not necessary to search. The driver get help during the picking the right pallets and bring it to the right lorry. So now it is from this step, the digital warehouse, it is easy to go the next step into the way of automatization. So the next step now will be that we use our AMRs carry to transport the pallets from the conveyor belt to the block storage autonomously. And this will bring another savings for the customer. Sure, we can reduce up to 20 FTEs. The customer does not need any manual workers in that process anymore. So in our opinion, this is also the right direction to step forward. So start with the digitalizing of all the complete warehouse processes, and then move the way into the autonomous world. So at the end, I would like to share some challenges which we see beside the tasks that we have many standalone solutions which are integrated at the customers, which does not have an integration to the WMS system. We see, in addition, that we have a difficulty to integrate different vehicles from other suppliers. We heard that as well today. The VDA 50/50 is a right step into that direction, but from our point of view, we need also international standards to integrate vehicles from international suppliers or other open source interfaces. And we do see also some logistical challenges for AMRs, which are currently not available on the market in a robustly way. So, for example, to make that block storage handling or to make the truck loading, stuff like that. So yeah, I would like to come to the end of my presentation. We are very often to discuss in a network. We are often to work in a network regarding this challenge, and I'm really looking forward to your questions. Thank you very much.
Thank you, Benedict. There has been a couple of conflicts with your presentation, but I believe we managed to follow you as good as possible. The presentation mode didn't work 100% correct, but no worries about that. I believe the general topic about WES is something that is really hot right now, and something many people and organizations look into, considering the increased amount of complexity in warehouses and the increased amount of different technologies you actually put in a warehouse. There's been a couple of times from my perspective where people put in one solution in warehouse and go for it, and that's it, often managed by a WMS directly or with a WCS in the middle. But now it's moving into the direction of having WES in more complex environments and in a way broader scale. So thank you for bringing up that topic, which I believe is one of the bigger challenges we are facing right now from the software perspective, which we also discussed with Tosja from SIG earlier today. So really interesting. Maybe a couple of questions or a few questions, considering the timing here, also for our next guest. But maybe you can explain a little bit on, besides AMRs, what are the technical capabilities your WES currently has, and what technologies you're looking into?
Yeah, so our WES is basically we give the customer the complete transparency of AMRs and manned fleets, and this is the biggest USP from our software. And I mentioned that challenge. For sure, we also get in contact with different customers which already has some other AMRs in place, but we are working with them together. We hope that VDA 50/50 brings us many possibilities there.
Last question from my side, because I'm not so much a software expert. Is there any typical ERP you need to have in order to connect your system, or is it basically free to choose?
No, it is. We are not married with one ERP or WMS system, so we have open interfaces which can be used to connect to nearly each system. So we are not married.
All right.
But did you see now just my first slide?
No, we clicked through it, but I think the synchronizing didn't work that well. So we tried our best to follow you through the presentation and make the next slide job. I think Julian did well so far.
Don't know, but at least we could hear you very well, and everybody who's interested in the topic, I think, understood fully what you wanted to point out, because the explanation voice-wise was good to hear and clearly understood.
Yeah.
So thank you.
Thank you. Bye-bye.
Bye-bye.
Last but not least, I would say, at least for today, because everybody who's in right now should be also attend tomorrow. But last session today, Flexqube. Per Augustsson. Per, are you already with us? There you are.
Hi, how are you?
Hi, wow.
Well,
At the first shot, we can hear and see you.
Great.
Sounds like a happy ending today.
Yeah. Greetings to Gothenburg, or where are you located?
I'm in Gothenburg at the moment.
Good.
Sunshine outside. Yeah, it's lovely.
Fantastic. So let's focus digitally the next 15 minutes. And we're looking very forward to your presentation. So it's your stage, and we have some questions later on for sure.
Perfect. I will open up my presentation. So, welcome to this presentation about cart-based material handling. My name is Per, and I'm the CTO and the co-founder of Flexqube. So today I will tell you about Flexqube, where we are coming from, and where we are heading with our new products. So what is Flexqube doing? We provide cart-based material handling So we have a wide range of customers, both in United States and Europe. For example, our biggest customers is Tesla and Siemens. So in the new Gigafactory in Berlin, most of the carts that is in operation there is provided by Flexqube. Most of our sales is within manufacturing, but of course we see a very big increase in interest and requests also from e-commerce and warehouse business. So I will share a short video showing an introduction to our company.
Inspired by Lego, the founders from Gothenburg built Flexqube with the aim to make their customers world leaders in intralogistics with their flexible yet simple solution. Beginning with only the 3 founders in 2010, Flexqube has grown swiftly to now serve more than 850 customers in 35 countries. With the e-cart concept, Flexqube merges the mechanical building blocks with digital ones and can proudly state that Flexqube is now an automation company that offers state-of-the-art material handling carts. As the world of material handling transforms with robotic applications, Flexqube is ready to take the next step towards its vision of moving material in every warehouse and factory in the world.
Great. So I'm jumping back to the presentation. So since the start of Flexqube, we have delivered more than 50,000 carts with 5,000 different configurations. And they are all configured and built with our patent and Lego-inspired building block concept. We have, at the moment, 2 main distribution centers, one here in Gothenburg, Sweden, and one in Duncan, United States. We were listed on NASDAQ in 2017, and that was also the starting point for our transformation into a recognized robotics company. And I think if we look at the companies working with automation, Flexqube is unique in the sense that we have a very solid foundation in mechanical carts and a solid knowledge in intralogistics. So I think we can bring an interesting perspective into the automation business. We have a strong growth. Growth is a strong focus for us, and our order intake in the last quarter increased with 159%, reaching $5.4 million. So what is actually driving the need for industrial carts? So we see 2 major trends. The first trend is mass customization, meaning that consumers are expecting a lot of different products and variants. And of course, this is putting a lot of stress on factories because they need to produce these models and they need an explosion of parts. And a key enabler to manage all the different part numbers is to use cart-based material handling. In e-commerce, we also see a trend that people are willing to buy more bulky and heavy stuff on internet. Also putting some stress on warehouse and e-commerce centers to be able to manage this type of items. And also in that case, carts are a very attractive solution to do that. But today, in this presentation, we will focus on manufacturing and the factory of the future. And we at Flexqube, we see the future factory to be very, very flexible, of course. The assembly lines, they need to take care of a lot of different products. different variants. Maybe you run petrol cars in combination with electric cars on the same assembly line. And in order to do this, you need to have storage and areas where you prepare the parts. And the parts are delivered in the correct sequence, to the correct location, to the correct assembler in the right time. And of course, this creates more or less a constant flow of material. So if we look at what is the key enablers for the future factory, of course, the carts, they carry the material from the warehouse to the assembly line. But also automation becomes more and more important, because that is the method to handle the more frequent transports in an efficient way. And last, the flexibility. Future factories must be able to adapt to a new product mix in an easy way. It could be changed political directions, it can be new technologies like electric cars, but there will be a lot of change, and future factories needs to be super flexible in order to manage this type of change. So automation, as we all know, it is very hot and everyone is talking about it. But the truth is, when you visit factories, you realize that this transition has not even started. In most factories, you have forklifts, tugger trains, etc. to move the material. And there is also a lot of challenges connected to automation, especially within manufacturing. So one first point is that when you move parts in a factory, the size and shape can vary a lot. So I put together some pictures from one of our customers making buses. And as you can see, we have made cards for tires, windshields, seats, and body panels. And they all have the different size and shape customized for these specific parts. More the cards, or in manufacturing, there is very tough requirements in terms of ergonomics, because in the end of the delivery, you have, in most cases, a human that will pick the parts and assemble it on a product. And that is a perspective that is truly unique for manufacturing, that you need to configure the ergonomics in a very efficient way. Also, timing. The timing of delivery is extremely important, because if the delivery is late, you can potentially stop a complete assembly line. And I think this is unique compared to, for example, warehouse and e-commerce, that is more forgiving. If a transport is late, it is not that big disaster as in manufacturing, where you actually will stop the complete assembly line. Last, also in manufacturing, you need to take material all the way to the final location in order for the operator to pick it. You cannot expect the assembler to walk out in the aisle, for example, to pick up the cart and place it line side. So there is a lot of challenges, and when we talk to customers, they confirm that there is things that needs to be worked on, and especially they highlight challenges in relation to lifting and towing of carts. And this is also something that we experience when we design carts for other vendors' AMRs. Discussions are always, or in most cases, ending up around a technical discussion to solve the integration between the two parts. We would like the discussion to be more focused on what really creates value here. We want to focus on efficiency. How should we present the parts in order to create most value for the assembler, for example? So this is something that we want to bring into the automation discussions, to really focus what creates value for the users. So based on this, the challenges and also the trends that we see, We have a clear vision of the future that material in future factories, they will be moved with affordable, self-driving, safe and reconfigurable motorized carts that are tailor-made for specific user cases. So you have a couple of carts supplying seats, you have a couple of carts supplying windshields, for example. That is a way to really achieve high efficiency and flexibility. And given the fact that the transports in factories are increasing, it's more or less a constant flow. And if we add to that we can expect a significant price reduction in automation, we believe that in the future we will reach at a certain point a scenario where it doesn't make sense to separate the cart and the robot. The higher delivery frequency, the lower will the ratio be between the number of carts and number of AMRs. So our take is modular and reconfigurable motorized carts. They can be configured to any size and shape. It's tailor-made for specific user cases. They are fully standalone, meaning that all pain points in relation to cart and AMR integration are removed. And they are also instant available. So that is also important to consider, that you don't have any aspects of planning, picking up and dropping off the carts. And this vision is present, of course, in our product development. We are not at the stage yet where it's realistic to have all the cars motorized, but everything we do is in that direction. We started 2010 with a modular building block concept. In the beginning, we used it to make carts. Now we also use it to make robots. In 2019, we launched our first automation product called eGuard Line. So that has a modular approach with standardized building blocks. You can compare it with Technics Lego, that you can configure into different motorized carts. We are using vision technology to follow color and line in order to navigate it. Now, this year, we are taking the next step with the eCart Navigator, which is a truly unique product in the sense that it is the first non-load carrying AMR. It is an AMR that we use to navigate motorized platforms. So it is one step in the direction of our vision. In order to develop this product, we have teamed up with what we see the very best technology providers. Of course, Wiferion, we have worked with them for a while now, and we are extremely happy with the system. So we use charge pad and battery, and it gives us a lot of flexibility in the design. We use Robotics for navigation, and we have a bunch of SICK equipment to make sure we have the highest safety on board. So this enables us, as I said, a robust and reliable solution to go with established partners, but it also helps us to reduce the time to market. So back to the Navigator. What is the Navigator? It is a non-load carrying AMR equipped with safety, navigation, and battery that can dock with motorized attachments through a standardized interface. It transfers power and data to the motors in order to navigate it. It's a long sentence, but you can imagine if you think about a normal AMR and you simply remove everything except the chassis, the motors, and the e-stops, and you package that. That is the Navigator. And the remaining parts, the chassis, motors, and e-stop, that is the platform, or as we also call it, the attachments. And by creating a smart interface between those, we can create a beautiful system with extreme high level of flexibility. So we can use one robot to move a lot of different platforms with different size and shape and function. And we are enabling this through a smart docking. Of course, we have a mechanical interface, and we actually use a docking interface that are also used on cobots. So that is a very proven method. In addition to this, we are also adding data and power. And our inspiration in this comes from the cobot business, where it is, for a long time, it has been standardized interfaces. You can easily exchange tools on the robot arm in order to perform different user cases. And we want to create the same simplicity, the same level of standardization, and the same level of flexibility, but within the AMR business. We need to have some innovation when it comes to the interface between robot and cards, because today there is simply no standardization at all. So I will switch over to the next video. I will need to stop first here. I will change. So this video shows the navigator docking to a motorized platform. And in the first step, you have the mechanical docking. Later on, you see that the navigator is lifted up and you have data and power. So in the moment where the navigator starts to move, it is no longer controlling its own motors. It is sending drive controls to the platform motors. So this is what makes the concept unique. So back to this, since we have also data and power in the smart docking, we have the opportunity to add e-stops, for example, on the motorized platform, adding a completely new level of safety. If you have a robot driving under a cart, for example, then the e-stops can potentially be hidden for not being accessed. And you can also add additional safety scanners on the attachments, for example. And from a customer perspective, this gives a unique level of flexibility, because you know, okay, I need one robot and I can basically create different attachments that are custom designed in order to move different material. So it gives a high level of flexibility. And when you have a change need, you know that, okay, you can always rely on the navigator, because that is a standardized robot with a standardized interface, and you can focus on adapting the attachments, because you know that they will fit together. So finally, I will show a real user case that we are working on at the moment. So it is an automotive manufacturer that wants to get rid of forklifts and use robots to replenish racks with automotive seats. So there is one picking location over here, and you have one buffer location. The replenishment rate is every 5 minutes, and the window to replenish is maximum 50 seconds. Otherwise, the assembly line risk to stop. So I'm changing to the last video. So we are using 2 navigators working together as a team. And we have motorized platforms with multi-directional wheels. So one navigator will basically remove the empty rack. And when that rack is removed, his friend will go and move the rack to the picking location. And meanwhile, the other robot has picked up a full rack and will deliver that to the buffer location. And I heard in previous discussion, you talked about the chargers. And in this case, you can see that we have a vertical location of the charging pad. And it also flexible in the means that you can simply place the charger anywhere as long as you have a power connector to that. Great. So that was my last slide. I will open up the presentation again. Thank you.
There we are again. Thank you, Per, for the interesting presentation, which has been also the feedback from the crowd. So well done, I would say. Maybe a question from my side. You started nearly 12 years ago, back in 2010, and
yes.
At this point of time, there was nothing regarding AGVs, AMR, or at least nothing that has been as big as it is of today. Is that a benefit from your perspective, having this deep understanding of manual operations and how it has been before automated robots and all that stuff?
Yeah, I think that is a unique position for us, because we have really been focusing, okay, what is creating value in terms of logistics, designing of the cards, designing of the flows and everything like that. So I think it is very valuable for us that we have that history when we're entering the automation segment. And I think we felt when we started to work with automation companies, when we didn't have automation ourselves, that it was extremely technology focused. Okay, it was how fast does the robot go? What is the amp hours on the battery? How many horsepower is the motors? We want to turn this around to, okay, what really creates value for the customer. So I think that is our perspective entering the automation business.
Yeah, that's actually a really interesting reflection and something I would agree on. At the end, the customer doesn't really matter about the technical specifications of each robot or stuff like that. It's more about the outcome. What is the benefit in my process, right? And I agree on that one. I believe it's a true benefit from your perspective to have that understanding. So really well done and interesting transformation you're currently into. Where do you see the challenges on this transformation from being how to say it, someone who is assisting processes with cards to a robotic company at the end, or a software company for that maybe also?
Yeah, I should be fully honest. It's more challenging than we expected. It takes longer time to transform into an automation company, but it's a little bit of a snowball effect that now we have hired extremely skilled people, and we are working with the correct partners and so on. So once we have this snowball rolling, it will go faster and faster.
Mm-hmm. One point from my view as well, and maybe also it reflects the question in the chat. So Per, the question is, does each card also require individual safety components to ensure complete personal safety? We had the discussion with Tosja from SICK. I'm quite sure you also had it on your slide of partners. So what do you think? The Navigator will not be able to cover all sizes of cards with the built-in safety components, or what's your reaction on that question?
I think in most user cases, we will not need additional safety on the motor platforms, because they are designed in such a way that you have a very good field of view anyway. But since we have a digital interface in the docking, we can add, for example, a scan grid from SICK to the cart. It's not safety rated like a PLD level, but it gives sufficient object detection for that type of speed.
Yeah, makes sense. Good.
Any further question from the audience, Julian?
Not from me as an audience.
I see a question from Nicola. Tomatis at Robotics if it's a patent, and yes, we have applied for pretty broad patents related to this concept for several years.
Good. So that's a safety as well for you.
That's kind of safety, agree.
Good.
Just does not require sensors. But thanks, Per. Really interesting presentation. There's been really good feedback. Not too many questions, but really interesting feedback about the presentation. Glad to see it, and thank you.
Thanks,
you.
Per, so much.
Thank you for the time. Amazing stuff.
Thank you.
Have a good time.
Bye.
Bye-bye.
So
let's wrap it up.
Leave everybody into the afternoon or day or wherever you are in this beautiful world. 50% of the future of intralogistics days are over. Tomorrow there's another session starting at 1300 Central European time. Julian, what's your feedback on day one? Any highlights? Any learnings already?
I think I learned a lot, and especially a quite interesting mix of different application. Although we were talking about AGV and AMRs today, there were so many different kinds of application, especially the last one with a new concept, how to transport cars without really load on an AMR. That's a completely different approach than the other ones we've seen. I remember Identpro or Safelog, where you had, of course, a couple of loads being able to port it. But in general, I'm also looking a lot for what's coming up tomorrow, because tomorrow we called it next generation intralogistics. So looking at the screen, not so many AGVs, AMRs tomorrow, but more surroundings and equipment material. I'm really looking forward to Pikavi and to Nimsta, some friends and from the startups time we have met. Also, Miners and Docs are good colleagues we have met over the last 2 years on our road, being a startup and growing into the intralogistic worlds. What's your favorite for tomorrow?
Really, really tough question. I'm really interested into everything. That's why I'm here. That's why I'm typically doing what I'm doing. I know a couple of these companies. I believe it will be interesting to see the discussion with Siemens, MHP, and also with the Wiferion guys. I think this is a highlight for me for tomorrow, but also in regards to all the startups and companies that I may know already, I can highly recommend to attend tomorrow and get a glimpse at least of what they are doing, what is going on in the future of intralogistics. And
so please,
at this point,
join us
tomorrow,
same time, 1 p.m. Don't forget to register. Second day, please register again, because you need to have a new login for the new day. If you haven't enough, if you had not enough AGVs and AMRs, tomorrow last session is Vaku Robotics, and I think they are also absolutely experts in AGVs, AMR. So if you didn't have enough today, please join us tomorrow. Andreas, thank you for being here.
One important fact: everything we discussed today is recorded and will be available on demand on YouTube, probably.
YouTube, yes. And of course, you always check out Wiferion.com. We, of course, highlight and link to the right connections and plans at YouTube.
Thanks for attending us and have a great day. Bye-bye.
Bye-bye.